In this video, I'll be showing you how to solve polynomial and rational inequalities, and I'm going to be using the graphing method. The other really popular, common method used is what's called the test point method, and so that's another method that works quite well. But this one can be done quite quickly. So it says here, use the graph of f of x equals minus x squared plus 4x plus 5 to solve the following. Well, first of all, this is where minus x squared plus 4x plus 5 is equal to 0. It's at this point here and this point here. This is a graph of basically y equals minus x squared plus 4x plus 5. Well, minus x squared plus 4x plus 5 is equal to 0 here and here. So when x is negative 1 and when x is 5. So here x equals negative 1 and 5. Those are the solutions to this equation. Now I want to know when minus x squared plus 4x plus 5 is greater or equal to 0. Well, notice here's where the y values are greater than 0, or basically where minus x squared plus 4x plus 5 is greater or equal to 0. Or, I'm sorry, greater than, actually it says greater or equal to 0, so we'll actually include these points as well. But up above here, I'm going to go ahead and shade this. This is where minus x squared plus 4x plus 5 is greater than 0, the part that I shaded in yellow here. So what are the x values for these points? Well, they go from negative 1 to 5. So you could write it this way: x is between negative 1 and 5. And because of the greater or equal, we're going to have a greater, well, less than or equal symbols here. So these are the values between negative 1 and 5, including negative 1 and 5. So negative 1 and 5 make this function equal 0. And in between here is where this function is greater than 0. All right? So now the last part here, it has minus x squared plus 4x plus 5 is less than 0. Well, remember, again, our y values, that is the value of the function here. So down here, the y values are negative, and they're here as well. So basically, keep in mind this goes forever left and down, so when x goes from negative infinity until x gets to negative 1, the value of the function is less than 0. So basically x is less than negative 1, or over here we have 5, and after 5 the values of the function again are negative as x goes from 5 to infinity. Again, this goes forever right and also forever down, and so x is greater than 5. That's where the values of x minus x squared plus 4x plus 5 are less than 0. So you can see here's where this function, which is this function here, is less than 0. Here's where we're equal to 0 at negative 1 and 5. And between negative 1 and 5, you can see the value of the function of this function is greater than 0. All right, so the last thing to do here is just write this in interval notation. It'll be negative infinity to negative 1. Those are the values that are less than negative 1. And we're going to union that with the values greater than 5, so from 5 to infinity. Now, it didn't say interval notation, but that's what we normally use if we have a set of numbers here. And so we're going to use this idea as we do the following problems. All right, so let's look at number 2. So we can actually make a very quick sketch of this graph quite easily. We're basically going to graph f of x is equal to x squared minus x minus 6. Now to find the zeros, or the x-intercepts, or where they're at, we find the zeros. And so this factors as, let's see, x minus 3 times x plus 2. And so x equals 3 and negative 2, those are going to be our zeros. So let's go ahead and draw a little sketch. This is my xy axis. And my y-intercepts for this graph, x-intercepts are at negative 2 and 3. And because this is a 1x squared, we know this graph opens up, and really all we need is a rough sketch here. So I'm just going to draw a rough sketch. I know it opens up and it goes through these two x-intercepts. I'm not worried about the vertex. I don't need that for what we're doing here. So we want to know when x squared minus x minus 6 is less than or equal to 0. Well, we know we're equal to 0 at negative 2 and 3. And the values, the y values, again, this is y equals x squared minus x minus 6. So these y values here tell us where x squared minus x minus 6 is less than 0. That's basically here. And again, because of the less than or equal symbol, we're also going to include these points, because that's where we're equal. And so our solution is the set of numbers starting at negative 2 and going to 3. All right, let's move on to number 3. Now, we could do this by just drawing the just graphing this on our calculator and drawing a rough sketch here. I'm going to go ahead and use the details here to draw a sketch by hand. I'm just going to get the first 0 off the calculator. So you can see if you're graphing this, now as far as end behavior is concerned, that's pretty simple because this is a degree 3, so we're odd. It's an odd function and it's positive out front. And so that has the, what I call the John Travolta end behavior, where basically it falls on the left and rises on the right, just like y equals x cubed. For any odd degree, that would be the case. So that's our end behavior. And we have to find the zeros, and that'll give us our x-intercepts. And that's where this is a little more challenging because we don't have, we can't factor this by grouping. You can see that if you can factor out an x squared here, you get x squared times x plus 4, but you can't factor out an x plus 4 here. So factoring by grouping doesn't work. So you'd get on your calculator and you would find that 1 is a 0. And so we're going to basically divide this function, or this polynomial, by x minus 1. So when we do that, let's see, our coefficients here are 1, 4, 1, and negative 6. We'll drop the 1 here. Let's clean this up just a bit. And then we'll multiply. We get 1. When we are in the columns, we always add. We'll get 5 here. Multiply the 1 and the 5, you get 5. When we add here, we get 6. Multiply, we get 6. And when we add, we get 0, which is what we expect because we knew that x equals 1 is a 0, which means x minus 1 is a factor. So we can actually write this. Again, remember, we want to set it equal to 0 to find the zeros. So we have x cubed plus 4x squared plus x minus 6 equals 0. And we know that x minus 1 is a factor. The other factor is our answer here. Well, this was cubed, so we drop our degree by 1, and we'll have 1x squared plus 5x plus 6. So finally, we can factor that part right here. This is a trinomial. We can use the AC method. It doesn't really matter which method you use, but you should get, what's that, x plus 2 and x plus 3. And so our zeros are 1, negative 2, and negative 3. Now let's go ahead and make a Z and B table. We've got zeros of 1, negative 2, and negative 3. Each of these have one factor, so the multiplicity is 1, which means the behavior at each x-intercept is we're going to cross. So now we're ready to draw the sketch of the graph. So our zeros are at negative 2 and negative 3 and also 1. Our end behavior, we know we're going to go down on the left and up on the right. And then we're going to cross, starting from here, we're going to cross at each x-intercept. So cross, eventually you got to come back down and go through this one, you'll cross. And eventually we'll have to come back up and cross. And so we get a graph that looks like that. That's our sketch. So that's the most important thing, is coming up with the correct sketch. And so now we want to know when, we have a graph of f of x equals x cubed plus 4x squared plus x minus 6. We want to know when this value is greater than 0. Notice we're not including the equal case, so we won't include these points here, these values there. Greater than 0, the y values are greater than 0 here and here. So our solution goes from negative 3 to negative 2. Again, we're not including the endpoints because there's no equal symbol here. And we're going to union that with the x values starting at 1 and going from 1 to infinity, because from now on, as x gets bigger, this is always going to be positive. And so these are the places where our function x cubed plus 4x squared plus x minus 6 is greater than 0, which is what we want. And so that is our solution. If you plug in any numbers in this interval or this number or interval here, when you plug in that x value, it's going to make this inequality greater than 0. All right. So if you were just solving this and I didn't ask you for all the details for the graph, I mean, the most important thing is that you can come up with the x-intercepts and draw a sketch, and then you'll use that sketch to come up with your solution here. You should be able to do all of this by hand, but if you're just doing an inequality like this, you can use your calculator to help you do this. Oops, I'm going to keep using this, so I should probably keep it here. We just need to move down. All right. So I'm just going to do some preliminary work here to draw my sketch, and then I'll get my calculator to help me finish it out here. Again, these are functions that you should be able to graph. F of x equals 8 over x squared minus 4. And also f of x equals 3x over x plus 1. So first of all, we would want to find any vertical asymptotes. Those occur at our restricted values. And notice the denominator here factors. So you can see that we can't have 2 or negative 2 as input values. X could never be negative 2 or 2. And we know that's where we're going to have our vertical asymptotes. Horizontal asymptotes, well, notice the degree of the numerator is 0 and the degree of the denominator is 2. So the degree of the denominator is greater than what we have in the numerator. This is what I call bottom heavy. and when you're bottom heavy, your horizontal asymptote is y equals 0. So let's go ahead and put those in. Let's get that back. All right, so x equals -2. That's this one here. And then at x equals 2. And then at y equals 0. We have asymptotes. As far as a y-intercept's concerned, if you plug 0 into this, f of 0 would be 8 over 0 squared minus 4. Well, 0 squared is 0. 0 minus 4 is -4. You'll get 8 over -4, which is -2. So 0, -2 is an a y-intercept. 0, -2. And then, do we have any x-intercepts? Well, that only occurs if, well, first of all, your y value here, if you let it be 0, this fraction could only equal 0 if the numerator is 0, which can never happen, and so there is no x-intercept. So now I'm ready to go ahead and get the calculator, and it'll help me to finish my sketch. So let's go ahead and enter this in. I'm going to go ahead and make this just a little bigger. Hopefully that'll help. Let's see. We'll do that. I think that'll be good enough. So we're going to want to put in 8 divide parentheses x squared minus 4. Now, for some of you, if you have, well, this calculator actually, if you click on math on the far right, you'll see fraction, and you can use that to put in the fraction. Otherwise, you'll put it in like I do here. If you put a binomial or trinomial in the numerator or denominator, you're going to want to have parentheses. All right, so let's go ahead and do zoom and standard. And boy, this is not, I don't know why it's not picking that up better. Let me try something here. Second, let's make it more dark. I think it maybe is too bright. There we go. All right, that was the problem. It was too bright. Okay, so you can see we knew we had a horizontal asymptote at y equals 0. You can see that here, and you can also see that here's our asymptotes at 2 and -2, and you can see that our graph's going to look like this, and then over here it's going to look something like this on each side. So let's go ahead and solve this now. We want to know when we have a graph of this function, 8 over x squared minus 4, and we want to know when it's less than 0. So basically, we want to know when our y values, y is equal to this, when our y values are less than 0. Well, that happens here. Notice in this case, this never equals 0, but we don't have less than or equal, so that doesn't really matter. So our solution here is going to be -2 to +2. All right, so I'd encourage you to try number 5, doing the same thing, and then see if you can come up with the solution, and then watch the video. All right, so your vertical asymptote, notice here x will not be, can't be -1, that would be a restricted value. And so that's where you have a vertical asymptote. Notice the degrees, if we're trying to find horizontal asymptotes, the degrees of the numerator and denominator are 1, so this is what I call the balanced case, and it's going to be y equals the coefficient here over the coefficient here. It's the coefficients of the leading terms, so 3 over 1, so we're going to get y equals 3. And so let's go ahead and draw our sketch, or start drawing it. So we know when x is -1, we're going to have a vertical asymptote. Let me just move this down just a tad. And also at y equals 3, there's an asymptote. And as far as intercepts are concerned, the y-intercept, we'll find that at f of 0. Again, we're graphing this function here. It's going to be 3 times 0 over 0 plus 1. When you have 0 in the numerator, 0 divided by a number here, you're going to get 0. So 0, 0 is actually your x-intercept and your y-intercept. To find any intercepts, you set your numerator here equal to 0, and x equals 0 is the only one you'll get, so there are no other x-intercepts. And so, again, let's go ahead and put this into the calculator to finish our graph. So it's 3x divided by, actually I think I'll go ahead and I'll do it the other way so you can see that. So I'm going to hit math, and you can go to the far right and choose fraction. Again, this is only for those that have that feature, and you'll see it's a little bit nicer as far as putting the function in. If you don't have this feature, then you're going to have to put the x plus 1 in parentheses. So again, we want to make sure we hit zoom standard. We already used that before. And you can see that, you know, we've up at 3, we have our horizontal asymptote. It looks like at -1, we have our vertical asymptote. So all we need to do is draw in our curve. So it's something like this. And so now we're ready to solve this. We want to know when 3x over x plus 1 is greater or equal to 0. Well, notice we're equal to 0 right here. And our y values are greater than 0 here. But don't forget about over here as well. So we're greater or equal to 0 from -infinity until we get to -1. Not including -1, there's a vertical asymptote there. And then we'll union that starting at 0, and then from now on, because this continues forever, right? So 0 to infinity. So again, these are intervals of x values. When x goes from -infinity to -1, this function is greater than 0, which is what we need it to be. Notice here we're equal to 0. That's why we're including 0 in our solution. And then from here on, we're greater than 0. Our y values are positive. And so that would be from 0 to infinity. And so that's our solution. So again, if you choose any number in this interval or this interval and you plug it into this function, it's going to be greater or equal to 0. If you choose something that's in between there, 0 and -1, that would be in here, you would see that it doesn't work. Alright, so that's it for this video, and let me know if you need anything or have any questions.